Hi everyone. Yesterday we learned about a line. Today we're going to learn about a line segment. And the word segment means a piece of something or a part of something. So a line segment is kind of like a line, but it's not the whole thing. It's just part of it. So I'm going to say our line segment, you got the 2 points. Remember we said a line goes through 2 points, but it keeps going forever. Well, a line segment doesn't keep going. It stops at those 2 points. Now, when we're naming a line segment, you have to be careful because it looks a lot like a line. But what you want to do is you want to take the 2 endpoints where it starts and stops. You want to use those 2 letters, but instead of drawing a line over the 2 letters, you draw a line segment. So let me compare with what we did yesterday. Let's say, for example, I had 2 points. I'll call them point A and point B. Now, yesterday we had a line that went through them, continued forever in both directions. That would be line AB. I would write the letters A and B and write a line over it. Now let's do this instead. Today, we are going to have a line segment that goes from A to B and just stops. It doesn't keep going in either direction. It doesn't go through A, it doesn't go through B. Now what I would do if I'm naming that, I don't want to do this. I don't want to put AB with a line over it. I want to use this one right here, AB with the line segment over it. So you don't want to get confused between the two. A lot of times if you're reading our book, if you're looking at the homework in the book, you see line AB, you see line segment AB, you can be kind of confused between the two. Make sure you look for the little arrows in the notation that tells you what it is. Okay, now here's another thing that's a little bit tricky. If I say, this is the same notation I just used with you, if I say this notation, AB with the little line segment above it, then I'm talking about line segment AB, the line segment itself. If I say AB with no line segment above it, what I'm actually talking about is the length of the line segment. So if I said AB equals 10, I'm saying I have this line segment that's 10 inches long or 10 miles long or whatever the unit is. So that's another thing that can be a little bit tricky is the difference between this from yesterday. This means line AB. This from today, line segment AB. And this, oops, pen's not looking great right now. Let's see if we can get this. Okay. Where you're actually going to tell me how long the line segment is. Like I said, maybe AB equals 10 or something like that. So you got to be real comfortable with the notation to be successful in geometry. Okay, now I want to talk to you guys for a minute about logic. This is another part of geometry. It's kind of, it maybe seems a little odd because it doesn't really seem like something we're going to be doing, but we're going to be working with logic a lot. And that has to do with rules, math rules. So a theorem is a math rule that has been proven to always be true. You know, people for hundreds and hundreds of years have been studying math, and they've been, checking these different things that they say, okay, I think, it seems like this is always true, and then somebody proves it, and once it's proven, it's a math rule, and we can use it. Now, a postulate or an axiom, kind of two words that essentially mean the same thing, that's another type of math rule that isn't proven, but we accept it as true. They're usually very basic and simple. And in fact, they're kind of so simple they can't be proven because they're just obvious. And we call that a postulate or an axiom. Now, we're going to be working with these a lot for the rest of the semester. But basically what we want to do is we want to learn all these different rules. It doesn't really matter if it's a theorem or a postulate or an axiom. We want to know the rules themselves. So we're going to learn a lot of these rules, and we're going to learn how to use them throughout the rest of the year. And the reason I bring that up, we're going to learn our first one today. So this one is called the segment addition postulate. Now, a postulate is a rule. Technically, it's the one that's pretty simple, like it hasn't really been proven, but we accept it as true. But like I said, that part isn't really that important. The rule itself is. Now, segment addition means it has to do with adding up line segments. Now, here's what it says. In this picture right here, so I have a line with, or a line segment with 3 points on it, A, B, and C. And it says AB, which would be this, plus BC, which would be this. And remember, since I didn't put a line over them, I'm actually talking about a number, like the length of each one. Now, AB plus BC equals AC, which is the whole thing. All of that. Pretty obvious, right? I mean, you take two line segments and stick them together, the whole thing is going to be the two added together. So that's what a postulate is. Pretty easy. We don't need to prove it because it's just obvious. Now, just so you know, our book calls it betweenness of points. Most books call it the segment addition postulate, but our book calls it betweenness of points. It doesn't really matter what you call it, it's the same thing. They call it that because it's about having a line segment with a point in between them. So B is in between points A and C. It breaks it up into two pieces. The two pieces add up to the whole. Same concept. But here's how you might use it. So here's a question where we want to solve for x. And it's that same picture. It's a line segment with a point in between it. Point B is in between A and C. And by what we just learned, whether you call it segment addition or betweenness of points, this piece on the left plus this piece on the right, if I add those two up, it has to equal the whole thing, which is the 43. And that's what it means. If you see that 43 and then kind of the brackets, that's how they're showing you the whole thing is 43. And again, whatever we're measuring in, inches, centimeters, meters, whatever. So what we're going to do is we're going to set up an equation and solve it. So I'm going to take the two things I circled and add them together. I'm going to do x plus 4 plus 3x plus 7. And I'm going to say when I add those two up, it has to equal 43, the total. Now that's my equation that I want to solve. So we're going back to equation solving, which we did in first semester. I'm going to put that dotted red line in there to remind me. When I'm solving an equation, I can do anything I want to the equation as long as I do the same thing on both sides. But before I do anything to both sides, I have common terms. And anytime you have common terms, you want to combine them. So like right here, I have an x and I have a 3x. 1x plus 3x is 4x. And right here, I have a 4 and a 7. 4 plus 7 is 11, so I'll just change that to plus 11. And I'm going to leave the 43 for now. So I combined my like terms. I added my x's together. I added my numbers together. Now we're ready to do the actual solving. And I think what I would do for my first step is probably subtract 11 from both sides. Let's get rid of that positive 11 there. So I'll do minus 11 on both sides. Cancel that out. That leaves just 4x here. 43 minus 11 would be 32. And then the last thing I want to do to solve for x is divide by 4. So if I divide both sides by 4, that 4 cancels with that, and my answer is 32 divided by 4, which is 8. So your final answer is x equals 8. There were two steps to this type of problem. Number one, use the postulate to set up the equation. You had to look at the picture and realize that x plus 4 plus 3x plus 7 equals 43. Then you write that down and you have the solving part. So it's almost like two separate questions. You have to know the postulates and the theorems to set up an equation, but you also have to know how to solve the equation. Okay, here's a little bit more vocabulary for you. Number one, this is a very important word for us. The word congruent is any two shapes that are exactly the same. It's kind of like equal, but you want to remember equal is for numbers. Like I can say 10 equals 10 or x equals 7. If I'm talking about numbers, I can use equal. For shapes, you don't usually say equal. You say congruent. Now, since congruent, it's pretty much equal for shapes, the sign is almost the same. You use the equal sign, but you put a little squiggle above it. So that red symbol right there, that means congruent. So if you ever see an equal sign with a squiggle over it, it basically means equal, because congruent kind of means equal, but what it means is you're talking about a shape instead of a number. So you might have two triangles that are congruent, or two line segments that are congruent, or two angles that are congruent. Those are things that are congruent instead of equal. Now here's a picture. I'm going to take me out so you can see the whole thing. Here's a picture of four line segments. We have AB, we have CD, we have EF, and we have HG. Now notice there's some markers on here, like on the two smaller line segments, EF and HG. I put one little red mark on each one right there. That means those two line segments are congruent to each other. So EF and HG are the same. They're equal, they're congruent. Now for the other ones, I wanted to tell you that the longer ones were congruent to each other, but they're different from EF and HG. So I put 2 marks on those. So 2 marks here and 2 marks here mean those two are congruent also. So what I would say is the first ones, the smaller ones with 1 mark on them each, I would say line segment EF is congruent to line segment HG because they each have 1 little mark on it. But then I also said line segment AB is congruent to line segment CD because they have 2 marks on it. And if there are more congruent shapes, you could use 3 marks and then 4 marks and then 5 marks. You know, just keep adding little tick marks or whatever you want to call them to show that you have pairs of congruent shapes. So let's use that to do another example here. We have a similar picture again with 2 line segments, or a line segment broke up into 2 parts basically, the betweenness of points. And this time I said AB equals 12. Let's mark that. So this part here is 12. And then I said AC, which is the whole thing here, is 3x minus 9. Now see, I didn't tell you what this one is. BC right here, I didn't tell you what that is, but I kind of did because I told you it's congruent to AB. So see how I put 1 little mark on each one? This mark right here and this mark right here means that AB is congruent to BC. Well, if they're congruent, they're equal. So if AB is 12, so is BC. Now, once I know that they're both 12, if I add them all up, it's 24. 12 plus 12 is 24. So these two together are 24. And that's my equation. So the 3x minus 9, which was the whole thing, all the way from A to C, has to equal 24, which is also the whole thing from A to C. And that's the equation we're going to solve. So I'm going to go off to the side here. I'm going to say 3x minus 9 equals 24. And I'm going to solve for x. So first thing I would do is add 9 to both sides, because I want to cancel that minus 9. Leaves the 3x. 24 plus 9 is 33. And then the second thing I do is I divide by 3. Cancels that 3. Final answer, x equals 33 divided by 3, 11. So again, step 1 is knowing the postulates and theorems and setting up the equation right. Knowing that because this one was 12, so is this one, so the whole thing is 24. And then realizing the whole thing was 3x minus 9. There's my equation.